Good morning students. Today our topic is Hall effect sensor. This Hall effect sensor is based on the Hall effect which is discovered by E.H. Hall. So what is the principle of Hall effect sensor? So here is the principle of Hall effect sensor. If a strip of conducting material carries a current in the presence of a transverse magnetic field, a difference of potential is produced between the opposite edges of the conductor. So first of all, we have to take a conductor and send some amount of current into the conductor and apply a transverse magnetic field. So what is meant by transverse magnetic field means we are applying the magnetic field perpendicular to the current carrying direction. Then that magnetic field is nothing but transverse magnetic field. Then a difference of potential is produced, otherwise a potential difference is produced between the opposite edges of the conductor, which is also perpendicular to both current carrying direction and magnetic field direction. So this is the principle of Hall effect sensor. The magnitude of output voltage. So here a potential difference is produced, that is known as the voltage. The magnitude of that voltage is always depends upon the current and strength of the magnetic field which we are applying. And the developed voltage is also known as Hall voltage, and this effect is called Hall effect. So come to the diagram of the Hall effect. So you have to listen carefully. This is the conductor or semiconductor. The length of the conductor is taken as D and the width of the conductor is taken as W. Here this is the x-axis, y-axis and z-axis of a semiconductor or a conductor, whatever it may be. Now we are sending I amount of current through the conductor. I is nothing but amount of current which is passed into the conductor. So the current is sending along x direction. The current is passing along x direction. That means the electrons are moving along x direction. Now we are applying a magnetic field which is perpendicular to x-axis. That means current carrying direction. So that's why here we are applying the magnetic field along z direction, which is perpendicular to the current carrying direction. So that's why the magnetic field is called transverse magnetic field. And the strength of the magnetic field is B. So B is the magnetic field strength or magnetic flux density. When we are applying magnetic field, external field, so due to this field always some force acts on the electrons. So whatever field we are applying, definitely due to the field some force acts on the electrons. Here due to the magnetic field some force acts on the electrons. Due to the force the electrons are reaching to the bottom surface. So the amount of force exerted on the electrons is nothing but Lorentz force. When we are applying the magnetic field, always some force acts on the electrons. That force is called Lorentz force. Due to the Lorentz force, the electrons reaches to the bottom surface. So that's why the bottom surface possesses negative polarity. So automatically the positive polarity is induced along the upper surface. So that's why here the electrons and positive charges are separated. Electrons and positive charges are separated, then a voltage is developed. That developed voltage is detected and it is noted using a voltmeter. So here we are using a voltmeter, so which reads the developed voltage. and this developed voltage is always perpendicular to both current carrying direction and magnetic field direction. So that's why the voltage is developed along y-axis, and the developed voltage is called Hall voltage. That voltage is measured using voltmeter, and this output voltage is always depends upon amount of current and magnetic field density. If B value changes, the output voltage is also changes. So with respect to B value, the output voltage is also changes. That means here the output voltage is proportional to the B, input magnetic field density. So this is the relation which is derived from the Hall effect. So what is the relation? The Hall voltage is always proportional to the applied magnetic flux density. So this relation is obtained from the Hall effect. Come to our Hall effect sensor. So sensor is always senses a particular parameter, and that is detected by a voltmeter. So here we give a constant magnetic field value, that is preset value. So here the B value is preset condition. That means we are restricted to a certain value. So we are giving certain B value, then corresponding to the magnetic field a voltage is developed. That voltage is called Hall voltage, which is determined using a voltmeter. If any magnetic field exceeds this preset value which is already given, then the corresponding voltage is also changes by the phenomenon of Hall effect. So that's why if any change in preset condition, that change is sensed by the sensor by the principle of Hall effect. So that's why this sensor is called Hall effect sensor. So here the output signal from the Hall effect sensor is the function of magnetic field density around the device. When the magnetic flux density around the sensor exceeds, changes a certain preset threshold, then the sensor detects and generates an output voltage which is called Hall voltage. If this value changes, the output voltage also changes, which is detected by a voltmeter. The Hall effect provides information regarding the type of magnetic pole and the magnitude of the magnetic field. Once again, this Hall effect sensor is also used as on and off switches. So first of all, in off mode, that means in open circuit, there is no change in magnetic field. It acts as a off mode. If any change in the magnetic field, then it works as a on mode. So in this way, this Hall effect sensor is also used as switch. That means off and on switch also. Here is the formula. So that output Hall voltage is always equals to RH into P into I by W. Here RH is called Hall coefficient. B is called magnetic field density. I is the amount of current. W is the width of the conductor or semiconductor. So always the output voltage is in proportion to the magnetic field density. So if any change in the magnetic field, automatically the output voltage is changes. So then that is sensed by our conductor, and the output voltage is measured. With respect to output voltage, we can estimate how the magnetic field is changed. Okay.